Hello, Jean-Marie.
Hello, Florian.
It's a pleasure and honor being with you. We know each other for a long time, but we never had a discussion like this, so it is long due. Please tell us something about your successful career, some of the highlights, shortly, in a concentrated way, because your activity is so rich. Just let people know, ordinary people, what your successes can be used and how they can be used to improve things in life.
Okay, 40 years ago I started as a PhD student, and then
40 years?
40 years, yes. Even a bit more than 40.
Okay.
I started as a PhD student and as a member, as a young scientist at CNRS, and I was interested in metallic glasses.
Mm-hmm.
So I did some work on the structural model of metallic glasses, and during that period in time I discovered so far unknown aluminium-based metallic glasses, which I patented.
So that was patented as a special discovery.
Yeah, and then I moved for a year and a half to the University of Cambridge as a research fellow in the Cavendish laboratory, where I did some extensive work on modeling metallic glasses, and I did this in Cambridge. A, because I was lucky enough to be a fellow of Churchill College, and B, because at that time the most powerful computer for scientific research was in Cambridge, and I used a lot of computing power. And a couple of years later, when the first paper of Shechtman was published, about the discovery of quasi-crystals, I realized that as counter-examples of metallic glasses in my patent, I had mentioned compositions which indeed, in fact, were quasi-crystals.
Non-periodic material.
So
non-periodic crystals, correct?
Crystalline, but not according to the conventional scheme of periodically repeating pieces of material. And this led me to work on the structure of quasi-crystals. I was among the very first to publish neutron diffraction patterns of these materials. And in the meantime, I realized that these materials had special surface properties. At that time, it was not very clearly identified what it meant in terms of physics, but at least I could see that there were low stick materials, low stick compared to metals, much more than Teflon, but also much less than stainless steel or copper. And I found that this was worth of an application. I started to work on coatings for frying pans, low stick frying pans, because the French, they like grilled steak, and it was perfect for grilling steaks. And from that on, I worked on the physics of quasi-crystals. I was among the very first to show that they have low friction, low thermal conductivity, and so on, which was a very rich period in my life. I published a lot of papers, and I was invited to many conferences. And in the end, you invited me at the SIPS conference to give a plenary talk, which was exactly on this topic.
Push-pull alloys.
Yeah, push-pull alloys and things like this. And getting older, I became the director of one of the laboratories in the École des Mines in Nancy. And when I was a director of the École des Mines, I realized that we could unite the different laboratories that were working on materials in Nancy, and with this I conceived the idea of a much bigger institute, which is the Institut Jean Lamour, the people who want to make fun, they say the Jean Lamour Institute. And this
But
institute,
you founded this.
I was the founder.
You
Yeah.
had the idea, and you went through the idea,
I
and you made it possible, and you
I spent 20 years on this project.
20 years.
Yeah, I started. No, not 20, a bit less. But I started just with the idea, and it took me some time to convince my colleagues. And when everyone was almost agreeing with this, the issue was to raise the money, because we had to relocate 350, 400 scientists in a building that was designed for this type of research. And the main point is that my young colleague Stéphane Mangin came to see me with a very clever idea, which was to gather all the ultra-high vacuum experiments in one piece of equipment, coupled with an ultra-vacuum tube, so that the specimen that was prepared in one place could be transferred to another place without seeing the atmosphere. Because even at the low pressure which is on the moon, you have only a few minutes to study a surface before it gets contaminated. So we have an instrument that has an internal pressure which is lower than that on about by 2 orders of magnitude, lower than that which is on the moon. And with this we can put together very different techniques, preparation techniques, characterization techniques, and even send the same specimens to industrial partners who have an idea for an application, without putting back the sample
the same
to
place in tube, yeah?
Yeah, in the same place.
Yeah.
So this instrument has now been imitated, cloned in China.
Oh.
Yes, so this unique experiment is now cloned in BB. Yeah, this experiment has been cloned by Chinese scientists who did more or less the same experiment, a bit bigger in China. But in Europe, I think it is unique of that size. There are smaller experiments available.
So your tube is 75 meters long?
It's a bit more than 70, yeah.
Okay.
With something like 25 different experiments, MBEs, laser deposition, XPS, Auger, and so on.
So that's a big contribution you did to the city. You created a new institute.
Yes, the potential it's often the case in Lorraine. The potential is there, but to make it visible worldwide, it is not enough to have separated extreme talents, people of extreme quality. They are visible when you reach a certain critical mass. If not, they are just lost in the background. And with this tube, I think Nancy has achieved a status in solid state physics and material science that was not there 10 years ago. Thanks to this building and thanks to the very significant amount of money that was offered for this by the city of Nancy and the urban community, the region of Lorraine, and the European structural funds.
So it's
and the state, of course.
So you had the idea, you had the guts to follow, you had the guts to convince people, you had the arguments to make them believe. You are able to raise the funds. You were able to build it, but not build a normal institute, having a tube that was unique in the world. And then you directed the institute for a long time, I guess.
I was in charge of the project in the CNOS has a special tool for preparing the fusion of labs. So we had this for 4 years. Then I became the director for 4 years, and I stopped in end of 2012 because I had some health problem. Then I had a successor, and the director who you have seen 2 days ago took over 3 years ago. So the story started around 2003, and now it is, I would say, in steady state. I forgot to mention, because it's equally important with the creation of the institute, was that I coordinated a so-called European Network of Excellence. I was not alone. I did this with Knut Urban from Jülich and Louis Schlappbach from Empire in Switzerland. And this is what really launched in Europe the field of complex intermetallics. So it was subsidized by the European Commission, and the idea again was to bring together the labs which were interested in that field. So we had, I've now forgotten, we had something like 24 labs from 12 different countries, more than 400 people. We had a European school based in Ljubljana. We had a gender equality system and so on. And this really started the work on complex intermetallics. Intermetallics was an old field in Europe, but the complex ones, it was totally new, and it lasted for 5 years, which means that with the institute at the same time and my own research and my PhD students, I was really to the top, to the edge even.
So huge activity, so intensive. So dealing with quasi-chemical materials or quasi-periodic crystals, and then proving a discovery of Dan Shechtman that was ridiculed in the beginning, and then you brought it into life, you showed the result, you showed the application, and Dan Shechtman got the Nobel laureate for something he was ridiculed in the beginning. He got it 30 years later, and you have given a big contribution on this. Then you jumped to intermetallic components. Then you had an idea and you followed up and you convinced people, and then you brought it to reality, and then you assured funding, and then you built a tube and the institute around the tube, which is very successful today, and then you build a network. Oh, too much. You enjoyed that?
Yeah, I enjoyed it very much.
Which one is the most difficult part in all this story?
The most difficult part was to secure what the steps which I could achieve one after the other. Because when you have to convince, especially politicians and high-level administrators, that your idea is worth a bit more than 100 million euros. When public money disappears, it is very critical that if you achieve a certain level, there's nobody who comes next day to say, no, this is all bullshit. You should not trust him. We have a better, or where we are is fine enough. And several times I was very close to collapse, and the idea was close to be abandoned, because some of my good colleagues came to say this. Fortunately, the mayor of Nancy at that time, André Rossineau, and his opponent, they were not in the same party, from Jean-Yves Le Déo, who was at the region. They were not politically on the same side, but they both supported this development of Nancy. And with these two people and a number of administrators around them, we could achieve the goal. But it was really, several times it was at the edge. And then finally, it became such a brilliant idea that today nobody says that he was against it, he or she. No, everyone is happy with it. So I'm happy that they are also happy.
So, what was the factor that really pushed it out of the edge? What was the key? What was the level to bring it out of edge?
I think the idea that was really central was the tube. Because the tube is not only an instrument that unites experiments, it unites people, it unites countries, it unites different fields of material science, chemistry, physics, tribology, and so on. And therefore, with the visibility it gives to the Institute, it was really a very good idea. And since the building did not exist, we conceived the building around the tube. So the tube was invented, and then we say the building must be like this. And if you have achieved that it will be this huge hall for the tube, then the other parts, they come to stick
around the tube.
Around the tube.
But this was the tube was the key factor, getting out of the edge and making alive again the idea. This was a convincing factor too.
That was a convincing factor. Other factors was that few members of the Institute became well known, including me. I got the prize, the Fray Award. Exactly. I got the TMS Award, and I'm the only French alive. The other famous predecessor, they passed away, and I was not the only one. Patrick Alno, who really gave birth to nanosciences in Nancy, was also a famous. So probably it was worth to bet some money on us.
What's the factor that brought together two politicians from two opposing, from competitor parties? How you were able to bring them together?
I did not bring them together. They
support the idea, I mean.
I think maybe this is an aspect of French politics, but they are supposed to support the general interest. The general interest of Lorraine is to get rid of the past, of this collapsing metallurgy and all the employment, to create a new region with some welfare. And people agree on this, although they have different political approaches, right, left, and so on. But they have a consensus on a few key actions which are related to the development of the region. And our institute is still one of the factors of development of the region. The virtual hospital, which we have visited yesterday, is the same, in the same mood.
So the most difficult part, as I said, is if I understand, if I concentrate in towards is dealing with politicians, correct? Or not necessarily?
No, you can imagine science. You can do research. You can teach, which is part of it. Yeah. But you cannot achieve a step further without the help of politicians. Correct. Especially today, the public money is become so rare, and they have the keys to decide where they make a focus. So you need to convince the people who are in charge of the general interest. The scientists are not in charge of the general interest, except very broadly. Exactly. But they are focusing at their target.
In a specific aspect.
Yeah.
Yeah, perfect. What about the easiest task? The easiest thing in all this career, what was that?
Probably PhD students, supervising PhDs.
Supervising PhD students.
Sometimes you are disappointed by the PhD student,
Yeah.
but you never know if it is the PhD student or the subject or the supervisor in teaching. But I had fantastic PhD students.
Okay.
Fantastic.
Yeah.
So in the picture which I sent you, there are a few pictures of Jackson Guedes de Lima, who became a friend, but he was one of my very first students, 3-4 years older than me, and I was 29, 30, and he became a very good friend.
You've been from the start, from an early stage, a full professor, correct?
No, I was not a full professor. I was a scientist at CNRS.
Oh, okay. He's a scientist, yeah.
But I was among the few people who were promoted very early.
Oh, okay.
So I became independent in the sense that I was...
Gives you freedom. And
yeah, I was a director of research at the age of 35, which is still pretty young, but much older than the mathematicians. But I was pretty young when I was promoted.
So, the most difficult dealing with politicians, the easiest one, supervising PhD students. So, taking decisions as a director, is this difficult?
Most of the time, no.
No.
No, most of the time decisions are standard decisions.
Yeah, stand-up decisions. You don't need to think about it.
It's, you have to find the money for the fellowship, buy the pieces of equipment, but this is never difficult. Sometimes it requires quite some work to fill in the forms and do the reports, but the difficult decisions are always related with the health of the people, not, and fortunately with young students this does not occur so often. As a director of an institute, this is another point, because then the bigger the institute, the more frequent you have these cases, but not with PhD students in general.
Yeah. Okay, so the best decision you have done in your life, you are proud of?
Oh, I would certainly say the institute. Jean Lamour.
Jean Lamour is your highlight.
And I still remember when I went to visit the director of the École des Mines. It was the director of studies. And I explained that we should do this and this, and this director became the president of the Polytechnic Institute 3-4 months later. And of course he supported me, and the head of CNRS also supported me. But the decision I still remember, and I asked him to write me a letter of mission to say what I have.
What will be the mission of the new institute?
Yeah, what I should do, and then I did the job.
And if I ask, what's the worst decision?
The worst decision?
In confidence, nobody is hearing.
No. There's at least one which I still regret.
Yeah.
Which was not to do electron microscopy myself. And so I started to do electron microscopy, but I had problems with my eyes. When I was a kid, I was forbidden, to do this game.
Oh, okay, because?
Because I was making fun of everyone. And my parents, they forbid me to do this.
Yeah.
And I think this is the reason. And later, it was painful for me. So because of the muscle, so it It gave me headache and so on, and I did not make electron microscopy myself.
So you also
And in 81, when I quenched the counter examples for amorphous state in aluminum-based alloys, there were some samples showing peaks. And showing peaks means not amorphous.
Yes.
So I used them as counter example to show where the area of the amorphous state is in the phase diagram. But I did not look carefully at them by electron microscopy. But in 81, I had a sample which was a quasi-crystal. Not only a quasi-crystal, but a stable quasi-crystal, which was discovered by An-Tang Tsai 5 or 6 years later. And because I decided not to do electron microscopy, maybe I missed the Nobel Prize. I did not discover the quasi-crystals. And Danny Shechtman, who did the job very carefully and with precision, showing that the whole sample illuminates. So it was not just a crystal oriented in a specific position, but the whole sample that was icosahedral, he deserved the Nobel Prize. And he got it later, but too late. But at least he was.
Because you've noticed them before.
I did not notice them.
Yeah, you saw them or something.
No, I made the composition. I made the composition which turned out to be a quasi-crystal, but I did not identify it.
I understand. So you produced it.
Yeah.
With quenching.
With quenching.
And then you saw that it's strange phase, but that was it, and that it actually through the you found out later that it was quasi-crystals.
Yeah, and the first quasi-crystals were made by quenching by Mel spinning. And this composition, it's aluminium, iron, copper. This refuses to become amorphous by quenching. It goes to a specific type of crystal, which is a quasi-crystal. So when you do X-ray diffraction, you see powder X-ray diffraction, you see peaks, which was enough for me to know that this does not give a metallic glass. But in fact, it was far more interesting.
Yeah. So what's the conclusion would be that you have to press on new things? And
no, it's today the young scientists, they know this. You need to use all the techniques that you can. Not only one technique. So when I was working on metallic glasses already, I used Mersenne spectroscopy, polarized neutron diffraction, EXAFs, but not electron microscopy. Unfortunately, this is the technique which you have to use when you do material science, and I did not use it.
Yeah. So you have conclusion then it has to be that we have to use all possible techniques, because you never know what the power of each technique is, the limits of the possibilities of each technique. They might be complementary, they might be similar, but you never know until you try it.
Yes, but yeah, it's true, but you need to get trained. And now training is during the first year of a PhD, training in all the different techniques is mandatory. In my time, you had one technique, the one of your boss, of your supervisor, and it was enough to do the research.
Yeah, very interesting story, really. If a new engineer, if you are a new engineer, if you are a high school student, if you go back 40 years and your parents tell you, what's your desire, what do you want to do? You're going to go in sciences, in metals, or law, or in sociology, or would you have chosen the same path? Back to the future, 40 years.
To do this choice is, I think it is totally different today and 50 years ago. Because the choice,
the field.
the choice of the field is depending on how much addicted you are to money. If you want to win,
one of the factors today.
if you want to own a lot of money, of course, you will choose finance, banking, and so on. But the key point,
Which is easy money.
well, the key point is that the young generation today, they are never sure that they will get a job, except, of course, the top level education system. In my time, this was not a question.
What was the question at the time?
To find a job was obvious.
Okay.
I never feared that I will be jobless. And then you can select the field. And I wanted to be a teacher first. And then I realized that I would not be a good teacher.
Teacher of what?
Physics.
Physics. In university.
No, in gymnasium.
In high school, yeah.
In high school. And so I went to the faculty and to be educated. And then I realized that this was not for me. I will not because I was obliged to give lessons here and there to get some money, and I was not patient enough. And then I met a very good scientist who proposed me to do research, and I started, this microthesis for a master degree, and I got the virus.
The virus of
research.
Of research.
Of research, and I was spending more and more time building experiments and doing furnaces to warm up the sample and so on.
And that virus, I guess, never left you.
No, I'm still doing research myself.
It's a good virus.
I still supervise a PhD student, and when I can put my hands on the experiments, I like to do it.
Yes, but I'm saying it's a good virus.
It's a good virus. It may kill you as well.
Why may kill you?
Because you can be exhausted. Because I remember I was doing a neutron diffraction experiment, and I got an hepatitis, and I was so exhausted that I fell asleep on the protection ring, so the neutron beam was close to my head, because I was so exhausted that I was sleeping with the head inside the neutron diffractometer.
And who woke you up, or you just by yourself?
Well, I woke up myself, but I was really tired.
Yeah. Well, I believe that. So a good virus, but you have to be careful not to overdo the job.
Yeah, you have to take care of yourself as well.
So it's a good COVID.
It's there is little chance that you have to be taken to the hospital because of this virus.
Yeah. Well, that's a very good line here. Research is a good virus. What's a bad virus, by the way? Not medically speaking.
Well,
just an example. There might be too many, but just anyone to come to your mind.
Yeah, but you know, people will say that I'm too old now to understand.
No, there's no too old. You're not too old.
I'm really desperate to see these young children at the age of a few years who are so addicted to their cell phone. They don't see their life anymore.
Yeah.
They live in a virtual
world.
In a virtual world.
Yeah, and this was made even worse by COVID.
And now it is a must. And now you organize a meeting and people say, why don't you do it on Zoom or on Teams?
Which nobody wants, by the way. Some of them want.
Yeah, but look.
That's not the life.
It's a pity. You cannot exchange on Zoom. You can exchange information that is pre-calibrated.
Yeah.
Something that is prepared to exchange it by Zoom is okay. If you do a scientific conference, and if of course you bring your own ideas, but if you do not listen to the other ones, stay home, save the money. What makes the importance of the conference is the ability to come with new ideas.
Exactly, interactive communication.
And this you will not achieve on Zoom.
Yeah, sure, 100%. That's why we never planned, even thought about to do any of our SIPs in Zoom.
Yeah.
Even in COVID times. So, wow, that's perfect definition. And so it's you have a virus, which is a good virus, but potentially, if you're not capable, I mean, very careful, you might get killed. So it's what about hobbies? So if you have a virus that makes you work and overwork, and sometimes even can get sleep dangerously because you're tired. What about hobbies? What about hobbies?
For
any time remaining for hobbies, is this virus allow you to cough on top on hobbies?
Well, for years I was a caver. I was doing speleology.
Oh, really?
When my equatorial diameter was of the size of my helmet, then I was doing caving.
Ah.
You see, now I'm not able to do anything like this.
How long? How long you did?
I did caving for at least 25 years.
Wow. Frequently?
Yeah, it was a patient.
Mm-hmm.
So I was in
how much of your time is it?
When I was a student, it was every weekend.
Every weekend.
And then I stopped when I was too old to be good enough. But 4 years ago, I decided to develop a new virus, which is astronomy.
That I know. Yes.
So I
guess it's a strong virus also.
Yeah, it's
so you have a big virus in research and two secondary virus in hobbies.
I think that the new virus, is going to kill the one before. Which
Why?
was
The big one, a research
because
one?
Astronomy, first of all, requires to learn a lot of things.
Yeah.
Second, requires time, which you take on your sleeping time, which is, in my age, it demands a bit of organization. But I have invested sufficiently in good telescopes.
Yeah,
and
I see that you own two observatories.
Yeah.
One in this backyard of your home. We took some pictures here, right here. So you cannot stay away from observatories. So you just go there and go inside there at night. And then you have another one, you own another one.
Yeah.
It's not just the others own and you go to use them. You own yourself, the lenses, the telescopes, and you build also the cupola of a real observatory. And the one we have not seen it yet is much bigger, correct?
It is better equipped, yeah.
Better equipped. So it's a virus.
Yeah, it's a virus. I use virus, but you would say patient.
I know.
It's the same.
It's a figuratively. We're using it just in a funny way. So, and then you go frequently every weekend, or how? No,
it's too far. So
But here, what about here? How frequently you use this one? Your backyard. So imagine you are the only scientist. I don't know even people that are dealing with astronomy. I probably am wrong, but I have not seen anyone bought observatory in the backyard.
No, there are many people.
Really?
Yeah.
Probably.
Because
probably in France, I don't know.
Well, the cost is affordable,
Yeah.
and
In the backyard. They have done it in the backyard.
yeah, as soon as you want enough.
So,
It's not the magnification is not the point. The point is the resolution. If
your
you
cat is doing meow, meow, meow here. He wants you to stop. We continue. That's okay. And
yeah,
then,
so the point is that you want to see small objects or small things on the planet. The only solution is to increase the diameter.
yeah.
If you increase the diameter, you increase the weight. And it becomes more and more sensitive to shocks or to whatever. So it's much, much better to fix it, protect it in a cupola, and have your observatory wherever you like, but fixed, not something like a small lens which you will move every day to bring it to the field. So you fix it, it's big enough, and then you watch whatever you like.
But it's an ending story that also. You always can get better and more experience.
Of course, it's like your cameras. You can always find one which has better characteristics. Yeah.
So that's the two hobbies, two major hobbies, equal to your main one. Main virus and two viruses in the hobbies. What about the family? It's so in which virus they are? Research, science, astronomy.
No, so I have two children, a daughter and a son. My daughter is a nurse for children in pediatry,
Yeah.
and my son is a guy. He is an interesting guy. When he was young, he told me that he will never do science.
Why?
And never do a PhD.
Why?
And never go to airplanes like his father,
Yeah.
who was
Why?
traveling.
That's interesting. That's an interesting
And
discussion. Why?
So because he did not want to be like his father,
Okay.
and then he did a PhD on ionic liquids,
Wow.
and
He chose himself, or you
no, he chose himself. First he became a chemical engineer,
Okay.
took a PhD on ionic liquids,
Yeah.
and now he works for the French company which produces the uranium material for civil nuclear plants.
Ah. Oh, that's good. He changed the mind himself, or you changed his mind?
No, I did not influence.
So he went at that direction himself.
Yeah.
He understood that this is the way to go,
Yeah.
despite what he was mentioning when he
So
was young.
he was for years he was in Namibia and then in Kazakhstan
Okay.
to work for uranium ore mining,
So
and now he's back to France, but he still works in this area.
because I've heard many stories between the daughters, boys, sons. They say to their fathers when they are engineers, even professors at university. And they say to them, some of them go to finance, some of them go to law, and then jokingly they say always when they are in dinners or something, we are finance, we are in the law, not like my father, engineering. Oh.
Yeah.
So these people are lacking money. We don't have that problem. So that's a general idea. It comes to money. So that's sometimes being in the family. Oh, what about your wife? Is it in science or?
No, she was a medical secretary.
Okay, medical.
She worked
so
at
especially that's
at the
medical
hospital.
science. Yeah, well. So, but in a family, it's good to have all science, or to have no science in order to be complementary. What's the best?
So we are the majority of people in the family are more on the science.
I know, but what is best, to have all science or science and non-science?
This I don't know, because
You never know.
I know only one side.
Okay, that's okay. So, well, this is a very interesting discussion. But if somebody, a young engineer, not young high school student, comes to you in a dinner, in a restaurant, tells you, tell me why I need to go to science, why I need to go to engineering. If I have an equal choice, I can choose anyone, a young, brilliant student. Why he has to deal with science and engineering when we know that easy money is made by other people, by other professions. Not always, but it's generally easier to make money, like finance people, banking people. Money comes by itself. You just by putting money somewhere, and you see what happens. You take a chance, you put all in the stock market, and then you could still lose the money, but most of the time they secure themselves. The money are made much easier without thinking, without going around, without thinking solution, analyzing spectroscopies, analyzing different chemical analysis. So the perception, and sometimes people go by perception, not by logic. The perception of society is easy money are not in science. So in science, you are you work like a horse, and then you are compensated like a like a cat. So
Yeah. But in science, at least if you work in fundamental science, in basic science, you create your own intellectual world. Mm-hmm. If you are a crystallographer, you see the atoms where they are. Mm-hmm. It's for me it is more magic than being in the world of rules, constraints, administrative, which are needed. For me, this type of constraints of human origin are more constraints than the laws of physics and chemistry. There are physics does not allow you to do whatever you like, but for me there is more space to dream, and this is clear with astronomy and cosmology. You can dream.
Within some,
of course,
within some
you do not invent
constraints.
You do not invent the galaxies.
Yeah.
They are there for you.
Yes.
This is the difference.
So what they should do?
They should do science.
Should that because
they should do. It depends how good they are in the different aspects. So
if they are in different aspects, equal in all directions, why they should go to science?
To dream. To dream. To make their own world.
So to turn their dreams into their
some reality.
Work,
to some reality, which is either the theory of a new phenomenon or a device that produces something. Yeah. But in science, but it's my mind.
No.
Of course, I totally accept that somebody has a different approach.
No, that's fine.
But in my mind,
yours.
My mind, I was modeling metallic glasses, and I was creating something that did not exist, because it was against the theory at that time, so on.
So dream and passion to make it happen.
But an architect, for me, is another example. Of course, you have to take care of the resistance of the materials, of the place where you build it, but the model which you make to build a building is totally free. And do it. Dream.
Dream and passion to make it work.
Dream and passion, yeah.
And money will follow.
And if you are if you are happy in your job, this is already
good. So compensation.
So then, of course, if you have a position of a professor in Japan or in Switzerland, it's better than in France. Because you will earn 3 times more money. but life will be also more expensive. So you have to but this is not in the foreground. It's not the first point I would think of.
Well, Jean-Marie, very, very interesting. As always, it's a pleasure and should count the time to be together, because it's always an exchange of very interesting things and very interesting ideas. And this is one of those. I really appreciate being with you. And before going on, I want to say, where you are saying I'm old. What is your definition of old? I don't see that you are old. You are fully.
Well, I'm a bit older than a few years ago.
That's the best.
To be old is not a biological definition for me.
Excellent.
It's
you mentioned it, a little bit older than previous years, which is relative.
Yeah.
It's
yeah.
relative.
But you remember in Hainan when I got the award, my Slovene colleagues were there, and I was very happy that they come for this occasion. And I mentioned that in the next 42 years.
Yes, I remember that.
And you know,
I just retired from Jean Lamour Institute, and where I worked for almost 40 years. And the next 40 years, I'll have a new career in the institute in Slovenia.
Yeah, but the main point is that this was 5 years ago.
Yes.
And I still have 42 years.
Excellent. A pleasure. And, thank you very much, Jean-Marie. It was great.
It was great. And
a pleasure.
Thank you for
all the ways, and we should have many occasions like
and
this.
thank you for coming to Nancy.
Oh, it's a pleasure. It's a pleasure. And thank you for inviting me.
So I hope that you discovered a number of unknown things, Mirabelle, Pâté Lorrain, so what we have here.
And I saw a new drink, Saint Florian drink.
Yeah.
40%.
And those who will watch this movie, they should also come to Nancy.
Sure. And I promise I'll come again at any opportunity.
Great. Thank you.
Great, Jean-Marie. Thank you.